Well, we have another question here. The question says that prove that the sum of 4 times 3 to the power of 2 minus k, k starting from 1 to the infinity is a convergent geometric series. Show all your calculations. Well, okay, let me write the question over here. So we have like 3.1. So we need to prove that the sum of 4 times 3 to the power of 2 minus k starting from 1 to infinity is geometric sequence. Okay. I would like to start by listing few terms of this sum. So now, if k has the value of 1, we sub 1 there. So this is going to be 4. Let me write it all. It's going to be 4 times 3 to the power of 2 minus 1 plus, if k is 2, it's going to be 4 times, it's going to be 4 times 3 to the power of 2 minus 2, and then plus 4 times 3 to the power of 2 minus 3 plus dot dot dot. It's going to be like that. Okay, let's simplify. This one makes 12 plus 4 plus 4 over 3 plus dot dot, so on and so forth. Okay, so this makes 12, and that makes, because the exponent here will make 0, that's going to be 0, and then 3 to the power of 0 is 1, and then 4 times 1 will be 4, and then over here the exponent here will be equal to just -1. Okay, so it's just -1, and then 4 times 3 to the power of -1. 3 to the power of -1 is just like to say 4 times 1 over 3, and then that makes 4 over 3. Now that we know this, we can work out the constant ratio. The constant ratio is equal to R will be equal to Tn over Tn minus 1. This is the constant ratio for this sum. Now, to prove that the sum is geometric, it's if the condition is that if the constant ratio is in between -1 and 1. Okay, this is the condition if it is convergent geometric series. Yes, then R will be in between -1 and 1. Now let's work out R here. R will be equal to 4 over 3. 4 over 12, I mean 4 over 12, and then this is a third. Therefore, and then a third is in between is between -1 and 1. So therefore, proven. Okay, and then the following question is question 3.2. The question says that if the sum of 4 times 3 to the power of 2 minus k, k starting from p to the infinity equal to 2 over 3, determine the value of p. Okay, let's just move like this. 3.2. So we are looking for the value of p if this sum here of 4 times 3 to the power of 2 minus k, k starting from 1 to the infinity. Okay, equal to 2 over 9. Now, what do we know? Actually, because we proved that this series converges, we know that this sum to the infinite will be equal to a over 1 minus r. Okay, and then a is the first term, t1, and then the first term here will be a will be equal to 4 times 3 to the power of 2. Actually, here k starts from p to infinity. So 2 minus p, that's the first term. Then what can we do then? We're going to write, okay, we're going to write like this sum is now 2/9, right? 2/9 will be equal to 4 times 3 to the power of 2 minus p all over 1 minus a third, because that's the value of r we did find for this series. Okay, regardless of the fact that here k starts from p, the ratio, the constant ratio, they call it constant because it's the same all the way through. The same ratio all the way through. So this will be then that means 2/9 will be equal to 4 times 3 to the power of 2 minus p all over 2/3. That's 1 minus a third. And then that makes what? 2/9 will be equal to 3/2 times 4 times 3 to the power of 2 minus p. So because, like, you know, when you divide a fraction of another, we're going to take the first part, okay, we're going to multiply by the inverse of this. Instead of me writing 2/3, I'm going to write 3/2, like over here. And then we can simplify this further, and then this will be 2/9 equal to we can simplify here. Okay, simplify here by 2. So we have left with 1 and then that 2. And that will be 3 times 2 times 3 to the power of 2 minus p. Then we can also, I know, okay, if I was working for myself, I could also simplify this 2 and that 2 here. So it simply means, okay, let's just do it. If I can simplify, you know, like this. I'll divide this side by 2, and I divide that also by 2. So this will be simplified. That also will be simplified. So we have left with 1/9 equal to 3 times 3 to the power of 2 minus p. Now 1/9 can be written as 3 to the power of -2. Okay, remember the law of exponent that says, okay, because, or maybe let's just write all these steps. 1/9 is like 1/3 squared, okay, equal to, and then these also, the bases are common. We can apply this law of exponents. The law of exponents here says that if you have like a to the power of m times a to the power of n, we're going to add the exponents. Okay, we're going to combine the two by adding them. So this will be 3 to the power of because this one has an invisible exponent there of 1, so this is going to be 3 minus p. Okay, and then this also simply means we can write 3 to the power of -2 equal to 3 to the power of 3 minus p. Why am I saying that? Because the other law of exponent says a to the -m equal to 1/a to the m. So here, those law of exponents can also be applied in the reverse order. 1/a to the m is like 1/3 squared. We can write it as 3 to the -2. Now, another law of exponents says that if you have like a to the m equal to a to the n, this implies that we're going to drop the basis and then equate the exponent. This is what we're going to do. In this case, we're just going to drop the basis here and then make -2 equal to 3 minus p. Okay. I'm going to move this a little bit up there. So if I move -p over, it becomes positive p. Okay, and then I move -2 over, it becomes +2, and then we have like p equal to 5. That's the value of p. Thank you.